Alright, so homework 13 says solving a value mixture problem using a linear equation. Usually these ones have to do with the amount it costs per pound or per number of tickets you buy, those kind of things. It says Raina's coffee shop makes a blend that is a mixture of two types of coffee. Type A coffee costs Raina $5.75 per pound. Type B costs $4.10 per pound. This month Raina had made 130 pounds of the blend for a total of $661.70. How many pounds of type B coffee did she use? So we actually have type A and type B coffee. It's only going to ask for one or the other, so be careful when you enter your answer in that you answer the one that they ask for. And since we have two different variables, it means we have to have two separate equations. One of them comes with the cost per pound. Type A costs $5.75 for every pound you buy. So if A represents the number of pounds, 575 times A would be my total cost there. Type B, $4.10 per pound. So $4.10 times B was the total cost there. The total cost of my purchase, $661.70. My other equation in this case has to do with how many pounds of coffee we did. B is the number of pounds of B, A is the number of pounds of A. We know that there was a total of 130 pounds, so we know that A plus B equals 130. Now in the ALEKS program, they're probably not going to show you much more than the two equations that they created, because there are a number of different ways you can solve this. On ALEKS, they're probably going to solve it by the substitution method, which is not my preferred method. I like the addition method better. I'm going to do the first one, the substitution method, which is I think how ALEKS is doing it, and then I'll do number 2 using the addition method, and you can decide which way you like better. So if I'm going to solve this by the substitution method, since I want to solve it in terms of B, I want to solve this other bottom equation so that the A is by itself, so I can substitute in for A. So do it for the opposite one as what you're solving for. So in this case, A is going to equal 130 minus B, and I'm going to move the B over to the other side. So if it says solve for B, solve your other equation for A. Then they're going to solve by substitution, kind of like we did on those last 3 we did. So they're going to replace the A up here with 130 minus B. So 575 times 130 minus B plus my 410B, as I smashed this all in here, equals 661.70. And so we took that, plugged it in up there so that our equation just had B's and didn't have any A's. Now I get to solve my equation using my distributive property. Again, use your calculator. 575 times 130 would be 724.1. Okay? 575 times minus B would be minus 575B, plus my 410B is going to equal my 661.70 as I smashed that in there. So just for sake of room, since I wrote really big up here, I'm going to subtract my 724.1 and combine my like terms. So if you take negative 575B plus your 410B, you get negative 575B plus 410B is negative 1.65B. That's going to equal 661.70 minus 724.1.
Negative 85.8.
Negative 85.8. Almost can read that 8. Negative 85.8. And so we're going to have to take our negative 85.8 and divide it by our negative 1.65 in order to find B, right? Looking at me funny, is it not coming out right? Oh, it comes out okay. What are you getting? 52. Good, that's what I got too. So B is going to be 52 pounds, right? Well, that would make sense that it should be less than the 130. If it was more than 130, we know something was crazy because we only had 130 pounds total. B is 52. So that is if you do it by the substitution method. The second one here says, at the City Museum, a child admission is $5.50 and adult admission is $9.40. On Friday, 4 times as many adult tickets as child tickets were sold for a total of $1,077.50. Well, this one we have to do by substitution. So on this one, $5.50 for each child ticket and $9.40 for each adult ticket. Our total sales, $1,077.50 would be our first equation. Our other equation this time doesn't have to do with a total. It says on Friday, 4 times as many adult tickets as child tickets were sold. So again, when you're reading through that, whatever's mentioned first is the variable that's going to be set equal to something. Which one was mentioned first? And that second sentence. On Friday, 4 times as many adult tickets as child tickets were sold. So the adult tickets were mentioned first in the sentence. A is going to equal the other one. 4 times the child's tickets. 4C. So if you're not sure which variable is supposed to be equal to what, look in your sentence and see which one did they say first. They talked about the adult ones. The adult ones are going to equal 4 times the child tickets. So this one we have to solve by substitution. We're going to replace the A with 4C. So 550C plus 940 times 4C is going to equal our 1,077.50. And so, of course, we've got to multiply here 940 times 4. So $9.40 times 4 would give me 37.6. So we can take our 550 and add it to our 37.6. Combine those like terms, we would get 43.1C equals 1,077.50, and then we're going to divide by our 43.1. $25? C is 25 then. Now it just asks for the child's tickets, not the adult ones, but do pay attention because on occasion they'll say how many adult tickets were sold and you've sold it for children's tickets, and of course would have to multiply by 4 then. Number 3, a web music store offers 2 versions of a popular song. The size of the standard version is 2.4 megabytes. The size of the high quality version is 4.9 megabytes. Yesterday there was 1,140 downloads of the song for a total download size of 4,411 megabytes. How many downloads of the standard version were there? So, if we talk about the number of megabytes, what should our first equation be?
S plus 4.9H equals 4,411.
Exactly. 2.4 megabytes for the standard, 4.9 megabytes for the high quality, for a total of 4,411 megabytes. Our other equation, back to like that first one, the total number of downloads. S is representing how many downloads of the standard version we have. H is representing how many of the high quality version we have. We know there was 1,140 total downloads. So I said, besides substitution, we could also solve this by the elimination or addition method. Depends what book you read. But if I am going to do it that way and I want to find out how many standard ones, what I want to do is eliminate the high quality ones. So what I would do is I would take this bottom equation and multiply it by the opposite of what's in front of the H. So multiply by a negative 4.9, everything in that bottom equation, so that I can make opposites. So using my distributive property here, I'd have negative 4.9s minus 4.9h. And then I'd also have to take that negative 4.9 times that 1,140. So if you multiply that out for me,
Negative 5,586.
negative 5,586. Then what I can do is add my first equation with that new equation so that I can eliminate the h's from my equation. So 2.4 minus 4.9 would give me take the 2.4s minus the 4.9s, you get negative 2.5s. This is going to cancel that out, so we don't have to worry about the h's. That was our whole point. Over here, we're going to take the 4,411 minus the 5,586.
Negative 1,175.
Negative 1,175. And then all we have to do to solve that is go ahead and divide. Divide by our negative 2.5, we get 470. And again, that would make sense because it's going to be smaller than the total number of downloads. So 470 would be how many standard downloads we have. It's up to you if you like the substitution method like we did on number 1, or if you like the elimination method by number 3, whichever way you want to do them. More power to you. We'll do more of those when we get to the chapter on systems of equations.